Hello, good morning student. How are you? What did we discuss yesterday? We discussed yesterday about the protection and deprotection of carboxylic group. There we have learned about DI, that is a diisopropyl diimide, or which is also known as NN diisopropyl carbodiamide, right? And today we are going to learn the one more important functional group, which is carbonyl. And as we know that carbonyl is a common functional group present in mostly aldehyde and the ketone, and therefore today's discussion is a protection and deprotection of aldehyde and ketones. So first one, aldehyde and ketones can be protected as an acetal or ketal. When they form as a acetal or ketal, they are highly stable under oxidizing reagent as well as reducing reagent. They are very highly stable, as well as in basic condition they are highly stable. But in a acidic condition we can introduce this group under the acidic condition, whereas we can remove it under the acidic condition only. It get cleaved very easily and we can regenerate, we can get the carbonyl group back as it is. So this is, and as we know that most of the nearly 75% of the organic compound containing the carbonyl group, which is aldehyde and the ketone, and therefore among these aldehyde and the ketone, aldehyde is more reactive than the ketone. Why aldehyde are more reactive than the ketone? If you see the structure, general formula of aldehyde and the ketone, the aldehyde means R-C double bond O-H. This is the general formula of aldehyde, and ketone we know that R-C double bond O-R dash. This is the structure of ketone. R may be aryl group or alkyl group. Here R and R dash may be as a alkyl and the aryl group, and therefore this is a ketone, this is a aldehyde. It is a more reactive than the this one. There are some of the electronic factor, or what we can call it as a structural effect, that can affect the reactivity of the organic compound, mainly as a inductive effect and the resonance effect. If you consider our steric effect, hyperconjugative effect, then tautomerism, hydrogen bonding, these are the some of the steric effect, or we can call it as electronic effect. They greatly affecting the reactivity of the organic molecules or organic compound. If you look at here R group, let us consider here is a electron donating group. Assume that one alkyl group is a generally electron donating group. They exert as a plus I inductive effect, and therefore, and but here are the two R groups are there. They producing a plus R inductive effect, and when they gives the electron to that carbon atom, the carbonyl group, it is electrophilic in nature. They get what we can call it as a get destabilized due to the electron donating group, or that charge get dispersed over there, and there the electrophilic nature of that carbonyl carbon becomes as a less, or we can call it as a double bond character is a decrease over here, and that's why the reactivity of this carbonyl group is less as compared to the aldehyde, because the magnitude of that plus I inductive effect is more in case of the acetone than this one. Okay, this is a little bit about the introduction about aldehyde and the ketone. Now let us see how they get protected and form as a acetal. Now as we know that the general formula of aldehyde is R C double bond O then H. If it is treated with simply with alcohol ROH in presence of H plus, you are going to get first one R then O R dash, you can call it O R dash, then here H you can write here OH. It is called as a hemiacetal. It is known as a hemiacetal, and hemiacetal further treated with ROH in presence of H plus, we are going to get the formation of RO R dash double dash, you can call it his O R double dash, and then this hydrogen. This is called as a formation of the acetal. The protecting group of aldehyde completely, that is called as acetal. If it is a half, then it is known as hemiacetal. Understood this one? This is the simplest representation of the acetal formation. When this acetal is a form, this one becomes as a very stable under oxidizing reagent or reducing reagent or in a basic condition. It doesn't get affected or doesn't get interfere in those conditions. Now let us look at the mechanism, how the mechanism takes place over there for the formation of mechanism of protection and deprotection can be carried out under acidic condition, and we are going to get back is RC double bond O H aldehyde and that alcohol back it is. So this is what we can call it as a this one acetal formation, and it get regenerated under the acidic condition. Now let us look at here mechanism of protection RC double bond OH. Now here RC double bond OH, let us see here RC double bond OH. What is this? This is a aldehyde, right? Aldehyde first treated with H plus in acidic medium. This lone pair which is present on oxygen atom pick up the proton from here. What do you get? R C double bond O H positive charge and this H as it is. When positive charge comes on that, it becomes as a very unstable, or this carbon atom, carbonyl carbon atom is a more electrophilic in nature than the simple carbonyl carbon atom, right? This one is a more electrophilic in nature, and therefore the nucleophile is going to attack over there. As we know that here R dash OH, the lone pair which is present on the oxygen atom is generally attacking on this carbonyl group. That positive charge get neutralized. The resulting compound we are getting here R then OH, this H as it is. Here you can write here H and this R dash. Now look at here, this oxygen atom has 3 bonds over there, therefore I am putting positive charge on that oxygen atom. And as we know that if the heteroatom carries the positive charge, that species become highly unstable. It trying to stabilize so that it what we can call it as a by losing the proton over here, you are going to get the compound RC OH, then this H, then O, R dash. This species is known as a hemiacetal, right? Hemiacetal. And now further this compound is treated as because this reaction is carried out in the acidic medium, and therefore there are availability of H plus. Now the lone pair which is present on the nitrogen atom, the lone pair which is present on the oxygen atom easily attack on that hydrogen atom, and you are going to get here R C OH, then this H O R. Now look at here CH2, one H from here. Now look at again their positive charge comes on that oxygen atom, and as we know that it becomes as a highly unstable in nature. The lone pair which is on the oxygen atom, it forming as a double bond over there, and this what we can call it as a there is a loss of water molecule in this case, and the compound we are going to get here R C, then H, double bond O, R dash. Look at here again is a positive charge over there, and this carbon atom now becomes as a highly electrophilic in nature. Now what is going to happen here? R double dash OH, second molecule of the alcohol we are taking over here. Now it is going to attack on this carbon atom, and then this neutralizing the positive charge. The compound we are going to get here R C, then this H, then O, here H, R double dash, you can call it as a positive charge on it. Here is a O and this R. Now as I already told you that if the heteroatom carries the positive charge, that is highly unstable in nature, and by losing as a H proton over here, you are going to get R C O R double dash and O R dash, that is a H. This is called as a acetal formation. This is a hemiacetal means half, and acetal formation means this is a acetal formation. So this is a mechanism of protection. Now the mechanism of deprotection. How the deprotection carried out? Let us see here. Mechanism of deprotection. Mechanism of deprotection. Mechanism of deprotection. Mechanism of deprotection, how it takes place? Let us see here step by step again, once again. Now mechanism of deprotection means we have this one R C O R dash, then O R double dash H. Now it is treated with H plus in a acidic medium. Now what is going to happen? The lone pair which is present on it pick upping as a proton over here, and you are going to get R O R dash H, positive charge on that oxygen atom, hydrogen, then this OR double dash we can call it. And when this becomes as a protonated, what is going to happen? This species is a what we can call it as a unstable one, and then moving like this, we are going to get here R, then C double bond O, R, here positive charge H. Now the OH from the solvent is going to attack over there, and we are going to get this neutralized. Then you are going to get R C O H, then O R and H. Then again the acidic medium, So this now H plus will pick up the proton from here, and you are going to get R, then O, H, O, H, then R double dash. Now here R double dash, then positive, as we know that the oxygen carrying as a positive charge, so this double bond is moving like this, forming as a double bond over there, and this get neutralized, or this is a leaving group, so that you are going to get R C double bond O and H. Aldehyde is a back. Aldehyde. So this is a mechanism of deprotection, how it takes place. That is if you observe this mechanism carefully, you come to know that one, right? This is a formation of that acetal formation, right? Understood this one? If this aldehyde, if you take instead of so this is the acetal formation we have seen. Let us look at another one. Which one? Suppose as a, if you consider here another one, suppose as a ketone. Let us see another one is a for ketone, R C double bond O R dash, right? Now it will be treated with 2 moles of alcohol OR double dash in presence of H plus. What do you get? You are going to get R O R dash O R dash and this R, and if you treat with acid, you will be getting R C double bond O R dash, and this is known as kettle. This is known as a kettle formation, right? This is a kettle formation. First one is a hemi-kettle formation, and then kettle formation. Remember, acetal means what? Protection of aldehyde group. Whatever resulting compound, that resulting compound is known as acetal formation. If the protection of the ketone can be carried out by using this type of the reagent, then we can call it as a kettle formation. Now let us look at as a mechanism, how it takes place. Mechanism of that kettle formation. Here, as we know that R C double bond O R dash plus H plus. As usual, we know that lone pair which is present on the oxygen atom will pick up the proton, and you are going to get here R C double bond O H, then R dash. Look at here, oxygen has 3 bonds, therefore positive charge on that oxygen atom. Now the molecule of that alcohol is going to attack on that carbonyl group, and you are going to get here R, then C O H R dash, and then O R double dash. You can consider here R double dash, so that here H, positive charge comes on that oxygen atom. And now what is going to happen here? Then further there is a loss of proton over here, minus H plus. You are going to get here R, then C O H, then R dash O R double dash, right? Then next one, still acidic medium, it will pick up the proton from here. You are going to get R C, then OH2, positive charge over there, R dash, then O R double dash, right? When this happen, now the lone pair which is present on that oxygen atom forming the double bond with this, and you are going to get here R C double bond O R double dash, this R dash. positive charge on that oxygen atom, it becomes as highly unstable. Then further another molecule of that alcohol is going to attack on this, because this carbonyl carbon is a highly electrophilic in nature. So this nucleophile is easily attacking on it, and you are going to get R, C, R dash, then here O, H, R double dash, positive charge comes on that oxygen atom, and look at here O, R, and now this proton is easily lost, so that we are going to get the resulting compound R, O, R double dash, O, R double dash, and that R dash. So this species formation is called as a kettle formation. There, this is a hemi-kettle formation, right? Hemi-kettle formation. This one is a kettle formation, right? So this is a mechanism of protection. Mechanism of protection. Now let us move on to the second point, that is a mechanism of deprotection. Let us see the mechanism of deprotection. Mechanism of deprotection. So how the mechanism of deprotection takes place? Let us see over here. As we know that the protecting group of this RO, R dash, then O, R dash, then R dash, you can call it here. Now deprotection can be carried out under the acidic condition. The lone pair which is present on that oxygen atom pick up as a proton, and you are going to get R. For sake of convenience, we can write this properly. Let me draw properly here. OR dash, and here OR, and this is R dash, and this is going to lone pair which is attacking on that proton. You are going to get here O, R double dash, positive charge comes on it, and then this R dash and this O double dash, right? Now this species is highly unstable. The lone pair forming double bond over, pushing that alcohol as a neutral molecule. So R, C double bond O, R double dash, positive charge comes over here, and this R dash. So that what do you get? This one. Further, the water molecule H2O, right, which is going to attack here, this get neutralized, so that we are going to get R, C, O, H, then O, R, then R dash, and then now further the reaction is carried taking place in acidic medium. Therefore it will pick up the proton from here, and you are going to get R, C, R dash, then OH, this OH. Then now look at again, oxygen atom carries has 3 bonds over here. Therefore positive charge comes on that oxygen atom. Whenever positive charge comes on that oxygen atom, that species become highly unstable, and it forming as a double bond over there, that alcohol get removed, and you are going to get the final product R, C double bond O, R dash. That is nothing but as a ketone we are getting over here. So this is a mechanism for kettle formation, right? So this is all about the protection and deprotection of aldehyde and the ketones, right? Now let us move on to the next one. Before there will be a formation of what? The formation of hemiacetal, or what we can instead of this, if you use as a thiol over there, similar mechanism can take place over here. If instead of alcohol, if you take as a thiol over there, what do you get? The same. Suppose let us see here R C double bond OH. This is our aldehyde, right? This is the general formula. Aldehyde, when it is treated with 2 moles of thiol R instead of oxygen, there is a sulfur atom SH, that is called as a thiol, right? Thiol in presence of H plus, what you are going to get? Formation of the thioacetal. Here you are going to get R, then S R dash, you can call it as a S R dash, then H, right? And deprotection can be carried out in acidic medium, and the resulting compound will be formed here, C double bond OH, right? This is called as a thioacetals. This is known as a thioacetals. Mechanism is a similar, only what is the difference? Instead of oxygen there is a sulfur. So mechanism remains as it is, there is no thing. So this is first about aldehyde. Second one, if you have another one, RC double bond O R dash, that is a ketone, as we know that it is a ketone, and this ketone further treated with 2 moles of R dash thiols in presence of H plus, this is called as a thiol again, open chain, and therefore what you are going to get? You are going to get R C S R dash, then S R dash, here is a R dash, and the deprotection can be carried out under acidic condition, and you are going to get R C double bond O R dash, which is a ketone as it is. So their mechanism, whatever mechanism we have seen just now, this is a thioketone. This is known as a thioketals, right? Thioketals, and previous one is a only acetals and the ketals. Here sulfur atom, and that's why thio word comes before the ketal word. So that's the difference. The mechanism, other thing, everything is the same. Introduced under acidic condition as well as removed under the acidic condition. I think with this, let us stop today here. Remaining we will see the next lecture. Thank you. Have a nice day.